Hello everyone. Today we're going to talk about programming languages. We use programming languages to describe what we want the computers do. In other words, code is written in programming languages, and they eventually are turned into machine code in order to run. Depending on the conversion mechanism, we can classify programming languages into three different categories. The first category is compiler-based, such as C++ or Java. Code needs to be transformed by compiler and linker. Compiler usually performs two tasks. One, check if the code is written correctly, and two, generate intermediate code and optimize. On the other hand, linker converts intermediate code into OS-readable executable format. For example, ELF format on Linux or COFF format for Windows. The executable file usually consists machine code plus additional info for OS. Java is a special breed in this type. Java compiler generates Java bytecode. The Java bytecode is stored in a class file, and Java bytecode is consumed by Java Virtual Machine, JVM. JVM loads the class file and executes them on behalf of the host OS. Therefore, JVM is both the linker that loads all dependencies on the fly and application loader to run the app. In Android, Dalvik and Android runtime are used instead of Java bytecode. It's a bit complicated and we will detail later in the class. The second category of programming languages is interpreter-based, for example, JavaScript. JavaScript is loaded into browser as a plain text file. The JavaScript engine inside browser compiles and generates intermediate code, then executes the intermediate code. This process is usually called JIT, just in time. Many script languages have found great usage of this design because scripts usually require quick iterations during development. A complicated compilation linking process will hurt productivity. On the other hand, interpreters don't scale well. It's usually not a big deal to have millions of lines of code for Java, for example. Android has millions of lines. But if you had millions of lines of code in JavaScript, Houston, we have a really big problem. The last category of programming language is hybrid. They offer both compiler and interpreter formally. Formally means the default implementation supports both. Python is one of the typical example. Both interpreters and compilers are offered. It's up to developer to choose what to use. There are many different programming languages. Check out the Wikipedia. Why are there so many? Well, different languages fit different needs. Some people may suggest to prefer learning one language over the other and giving fake info like, oh, you will be paid higher if you learn XYZ. Believe me, 99.9999% of the time it's false. Don't get into these flame wars, by the way. Engineers are hired to solve problems, not to create more. Good engineers choose the right tools, and programming languages are just tools. Nothing less and nothing more. Just like sneakers and snow boots, depending on what you need, you will choose one over the other. For example, C is created in 1970s, and you can still see them in use today, because it's much easier to bring up a C compiler for early stage hardware firmware development. Other languages have their strengths. I list some of them on the slides, like C++, Java, JavaScript, and Python. There are also many new languages created recently, such as Rust, TypeScript, Kotlin, Swift. Again, these are tools created to better fit people's needs. So you might ask, how many programming languages should I learn? If you decided to pursue the career as a professional developer, you need at least 2 languages in your toolbox. I suggest one general language like C++, Java, and one scripting language like JavaScript. Of course, you better master the functional language conduct. If you did not plan to become a software pro, not learning any programming language is just fine. You don't need to feed a cow to drink milk. However, learning coding will help you better understand how pros think about computer. This usually helps you to be less frustrated because you'll have a better clue to use software even when the software is designed poorly. In some special areas, you need your own software tools to get your job done. For example, machine learning scientists in the early days before TensorFlow. There's nothing on the market and you need to create something in-house, so learning coding is definitely helpful. In case you're curious how many programming languages I learned, I am an expert in C, C++, Java, C#, JavaScript, TypeScript, and x86 assembly. I can do Python, Go, and Kotlin, but I'm not really an expert of those. I'm also an expert of Visual Basic, but unfortunately that language is dead. So let's briefly talk about assembly. Assembly is a special language that is processor dependent. For example, x86 assembly is very different from ARM. Assembly is designed to bootstrap compilers of other languages. It's usually called low-level language because it can directly manipulate hardware. On the other hand, all other languages are high-level, means they need some conversion to become machine code. That also means they are not bound to a specific processor. Usually the limit is what OS this code will run on. For example, you cannot easily run a Windows program on Android, even attempting to recompile from source code. The processor-independent feature is actually quite nice. For example, Android OS can run on both x86 and ARM processors, so it can support both hardware platforms. Some languages, like C or C++, have intrinsics. Intrinsics manipulate hardware resource directly. However, compiler can still determine whether or not to honor them. Now let's briefly talk about the C family. Many languages are derived from C, like C, C++, C#, Objective-C, Java, Kotlin, etc. Rust and JavaScript are syntactically similar. However, the philosophies of them are quite different from the C-based language. Well, we can talk more about philosophy when you are more familiar with programming. It's unlikely for one to understand advanced calculus without learning algebra first, and the same analogy stands true for discussing programming philosophy without actually mastering one programming language first. So the reason we want to talk about the C family is the C family has tremendous success. Almost 100% of commercially successful OS in this world is written in languages from this family. As a result, if you have no idea what language to choose as your first, pick one from the C family is usually not too bad an idea. And that's all for today. Thanks for watching.